us look at the question. The algorithm below is a binary search algorithm designed to search for a value in an array. So it's given you some pseudocode which relates to a binary search algorithm. Remember what binary search is, method for searching for a value. We study this algorithm first. So we see that there are line numbers on the side. So there are 12 lines in this algorithm. We see that array indexing starts at 1. So we know there is an array, and 3 is at position 1, 5 position 2, 13 3, 43 4, 6 5 5 5, 8 7 2 6. We see here lines 1 to 4 are inputs, and lines 5 to 12, there's a loop, a while loop here. And within that while loop, there's an if statement, and within that while loop, there are some assignment statements. Now, the reason we put line numbers in is that we're going to trace this table soon, and we can easily map the trace table to the line numbers. If sometimes they give you pseudocode without line numbers, I would strongly advise you put the line numbers in so that when you trace, you can easily see where you are up to by comparing it to the line number. So it's asked you to complete the trace table, first of all. It's given you a table, and this table is actually blank, first of all, with as column headings the variables val, left, right, mid, armid. So what do we do? Val, first value, now pretend it's an empty table, is 43 from line 1. Val equals 43. The second value, left, is equal to 1 from line 3. Left equals 1. The third value is right equals 6. Line 4. Right equals length of R. There are 6 items in it. And mid, okay, line 5, what's left is not equal to right. Well, 1 is definitely not equal to 6. So mid is equal to left plus right, div 2. 1 plus 6 is 7. Div 2 is 3. Remember, 7 divided by 2 is 3, remainder 1. So we take the integer part, 3. So 7 div 2 is 3. And then we have R mid, the third position of the array ARR. And the third position, we have the number 13. So that's the first line done. Then it says, no, not quite, line 7. If val is less than equal to armid, val is 43, armid is 13, so it's not less than equal to. So we don't execute line 8, we go on to line 10. Left is equal to mid plus 1. So mid is 3, so left becomes 4 if you add 1. Then you go round the loop again. So what's left is not equal to right. 4 is definitely not equal to 6. Mid equals left plus right, div 2. 4 plus 6 is 10. Div 2 is 5. If val is less than equal to array mid, now array mid is now 655 because that's at position 5. So once you've populated mid, you put in the value for armid. Val is 43, is less than equal to 655. So we don't execute, so we do execute line 8. Right is equal to mid. So right becomes 5 because the value of mid is 5. We go round again. Left, what's left is not equal to right. left is definitely not equal to right. So mid is equal to left plus right, div 2. 4 plus 5 is 9, div 2 is 4. And so R mid becomes 43 because R mid is at position 43. So if val is less than R mid, well, val is now equal to R mid. So we don't execute anything in this while loop now. We now exit from this while loop. So now we have traced the table. I strongly advise you go by it yourself several times. Tracing is fiddly. Now, next question. Why would the binary search algorithm not work when the array contains 5, 33, 13, 872, 655, 43? In a binary search algorithm, one of the prerequisites is the numbers in the array are in order. Could be in descending order, could be in ascending order, but they need to be in order. So the answer is the numbers in the array are not in order. Some lessons learned from this question. Please know how div works. 5 div 2 is 2. 5 divided by 2 is 2 remainder 1. So you take the integer part is 2. You also need to know what mod is. 5 mod 2 is 1. 5 divided by 2 is 2 remainder 1. So you take the remainder. Know how binary search works. Know how the binary search works, the mechanics of it. Know how the linear search works, the mechanics of it. Know what the differences and advantages, the comparison between binary and linear search. I will leave that to you. Now it says here, there are alternative statements to the one that could have been used on line 5 of the algorithm, which would not change the functionality. Shade 1 logence, to show which one of the followings could not replace line 5 in figure 4, as it would change the functionality of the algorithm. Well, it would be line 6. Why would that change the functionality? Well, you've got the statement left equal not equal to right. Write the statement out again here to see what you're talking about. Now, if you have this statement, what's left is less than right. Oh, actually, that's wrong. And left is greater than right. You could not really have a scenario whilst left is less than right and left is greater than right. It's a slightly, I think, absurd. Either left is less than right or left is greater than right, but it can't be both in this case. Think about it. Last but not least, let's look at this part, and it's asked you to write some pseudocode. Now, the point about this is that you need, first of all, to read the question a few times to understand it. When you do understand it, it's not really that difficult. However, you need to get to grips with the wording of the question. So let's read it. The final value of left in the algorithm is shown in figure 4 is 4. A programmer realizes that they can use this value to check whether val, that's the variable val, has been found or not in the algorithm shown in figure 4. So the programmer wants to extend the algorithm and introduce a new variable called found that is true when the value has been found in the array or false otherwise. So the variable found is true when you find the value that you want to find, and it is false when you don't find the value. So write the pseudocode or draw a flowchart that is needed to extend the algorithm, so when the algorithm finishes, the new variable found is true when val is found in R, or false when a val is found in R. Now, you think of this question in the context of the binary search algorithm. What are you doing in a binary search algorithm? You have a value, val, which is 43, and you are trying to locate it in the array. Or you might have a value, val 53, for example, and you're trying to locate it in the array. If val 43 is found in the array, then this variable found is assigned the value true. If you have a val called which is 53 and it's not found, the variable found is assigned false. Think about it for a second. You do need to read the question a few times to understand what it is saying, and then you have to locate the variables mentioned in the question to see how you can form the pseudocode. The variables mentioned are left, found, the values are true, the variables are found and val, and the values are true, false, and I think left here. So what you write for this question is if val equals ARR left, then found equals true. You're comparing the value val with the number in the array, then found. Remember, the question said introduce a variable called found equals true. Else, if it's not located in the array, found equals false. End if. See, it's quite a simple piece of code here. The hard part of the question is to know what the question is actually asking. But perhaps if you've read a number of questions and you've thought about them and worked them out, when you come to your exam, you should be able to work out what the question means. But it does mean reading the question a few times with intense concentration, and there is no way around that. So we've answered the question using pseudocode.